Good day, mates. All right, we're going to start our lesson solving multi-step equations. And even though it's called multi-steps, some of them might have an extra step, but for the most part, they're going to look mostly like two-step equations. So there's just a couple of new looking kind of equations I'm going to introduce you to. The first one is something that should be very familiar, what we just covered. This is a standard two-step equation. So you're going to start with the number that's by itself, but on the same side with the variable, which is a. So we're going to add 6 to both sides, work that out. Those are canceled. 2a drops down, equals drops down. 4 plus 6 is 10. Now we have a one-step equation where we'll divide by 2, and we'll be left with a equaling 5. And that's our answer. But when you look at the next one, this one looks different because you see the entire top part divided by a number. Whenever you see something being divided, like the whole thing, you want to get rid of your denominator. Just get rid of it first. And the easiest way to do that, if it's division, you're going to multiply, simply multiply both sides by the denominator, which is -2. And that works like 2 over 1, so those cross simplify. N plus 1 is left. 15 times -2 is -30. Now it's really simple. Just subtract 1 away. 1's are gone. N is left. -30 and -1 make -31. And there's your answer. Now, this one, again, is a standard two-step equation with division and addition. First number we're going to deal with is the 12. That's on the same side with the variable, the d, but it's by itself. So we're going to go ahead and get rid of the 12. That's the first one we want to get rid of. So we're going to put a subtract 12, cancel our 12s. -d over 6 drops down, equals drops down. -12 and -7 make a -19. Now, I see a 6 that's being divided. The opposite is always to multiply. So we're going to multiply both sides by 6. The 6's cancel. -d is left. And then you do -19 times 6 will come out to be, I believe, 114. -114. Now, what happens here is if you left the negative with the d, with your variable, which is what I showed on this time. If you accidentally do that, it's not wrong, you just have an extra step that you have to do because you cannot have an answer with a negative variable. So when you're left with the negative variable, just divide that negative away so you can have a positive d and a positive answer on the other side. It won't always be positive, but in this case it did. So it's positive 114 is the actual answer. I could have, back in this step right here, I could have taken the negative with the 6, and I would have avoided this second step of dividing with the -1. But if you don't, if you leave the negative with your variable, that's okay. You can still get rid of it. It's just an extra step. Let's go to a few more. Now, the first one here, 4 equals 3a minus 14. I'm going to skip that one. That's a standard two-step equation. We're going to go to the next one that has a fraction in it. The z is on the left side, so we're going to work with the -8 first, or the -8. The opposite is to +8, so I'm going to +8 on both sides. The 8's cancel. 5 over 2z comes down, the equal sign drops down. Now I'm going to work out my integer problem. -3 plus 8 is a +5. Now when you have a fraction that's being multiplied with a variable, the opposite is to divide, but when we divide fractions, we flip them and multiply. And when you multiply now with a whole number, you put your whole number over 1. Look to see if you can cross simplify first, and I can. My 5's cancel out to 1's. And now I multiply straight across. I'm left with z equals 2. Or 2 over 1, but you don't need to write the over 1. It's just 2. And then our last problem over here, it's kind of like the one I did a minute ago. When you see the entire side being divided, get rid of that denominator. So we're going to go times 4 on both sides. And we're just going to get that 4 out of the picture. 4 is gone. C minus 5 is here. 3 times 4 is 12. Then you've got a negative 5. You're going to put a positive 5 on both sides, or the minus 5, a plus 5. And you're left with C equaling 17. And that's our answer. You guys are free to check these. Just plug it back in. 17 minus 5 would be 12. 12 divided by 4 is 3. They do check. It makes it really easy to know if you're correct. The next thing I'm going to show you that you will see on your paper, your assignment you have to do, is when you're going to see problems like this off and on throughout the year, where you have to find 4 consecutive integers with the sum of 54. That means you're looking for 4 numbers, integers, that add, because that's what sum means, to equal 54. That's what you're trying to find. 4 numbers that will add to equal 54. And they have to be consecutive. That means in counting order, like 1, 2, 3, 4, 5. Above here is a chart. This is in your textbook too. But it gives you symbols to use when you're trying to find consecutive integers. The first one, since we don't know what it would be, we give it the name n. It's an unknown number. The next number would be the n plus 1. So if our first number is 7, our next number would be 8, which would be 7 plus 1 is 8. Then the next integer would be n plus 2. So 7 plus 2 would be 9, and so forth. That's what you use to represent your numbers for consecutive integers. So if we go down here, our first one is going to be called n. Our next one is n plus 1, then n plus 2. I kind of wrote these too close. And then n plus 3. That would represent our 4th consecutive number. At this step, I'm going to scroll down a little bit. All we do now is add up, combine our like terms first. How many n's do we have? 1, 2, 3, 4. So we have 4 n's, and then 1, 2, and a 3 add to be 6. 4n plus 6 equals 54. And what you're creating is a two-step equation. After you plug these in and condense them, you've got a two-step equation. So just solve it. So subtract 6, subtract 6. You're left with 4n equals 54 minus 6 is 48. And then the 4 would come over here to divide away because it's being multiplied, so we divide it away. And then n is going to equal 12. So if n is 12, n plus 1 would be 13. N plus 2 would be 14. That would be 12 plus 2 is 14. And n plus 3, 12 plus 3 would be 15. Here are your 4 consecutive integers. 12, 13, 14, 15. Now we're going to do it one more time, this time with consecutive odd integers. Let's go back and look at our chart real quick. When you're doing consecutive even or consecutive odd, it's going to be the same method. When it's consecutive even numbers, it'd be like 2, 4, 6. You're skipping one. So you have to add 2 and then add 4 and then add 6 and so on. So it shows you to skip one each time. Same thing works with odd. 3, not 6, I'm sorry. 3, 5, I was counting by threes. 3, 5, 7, and so forth. N would be 3. N plus 2 skips the 4, adds 2 to make it 5. So those are consecutive odd integers. So we're going to use one of those methods for doing consecutive odd. So we need 3 consecutive odd integers whose sum, so it's adding, equals 141. I'm going to use n for the first one because I don't know what that is. If it's odd, I'm going to skip one, so n plus 2, and then n plus 4. So I'm skipping a number. Now I'll add them together. I'll have 3 n's plus 6 equals 141. Subtract 6 away from 141. 3n is left. And then that would make 135. Divide by 3 to get rid of our 3. And n will equal, let's see, 45, I believe. And then n plus 2. And is that an odd number? Because these have to be odd. And 45 is odd. So n plus 2, 45 plus 2 makes 47. And then n plus 4 would be 45 plus 4, which is 49. Are these consecutive odd integers? And they're all odd. They are consecutive, means in counting order. And if you added them all up, you should get 141. That's how you know if you're right on that. All right, I know that took a little bit longer explanation, but I want to give you the problems I expect you to have for class on Friday. And there they are.